Hello, welcome back to Cracking the Cryptic, and thank you if you joined us on our stream last night where we completed the game The Return of the Obra Dinn and managed to close the book quite literally on that fascinating puzzle game. Not very PG, not very U certificate, I don't know what that's called, but lots of deaths depicted, but only in still pictures. And we solved them all in the end, but there was occasional bits of guesswork because I think that was literally the only way to get through it. I mean, it was a really interesting game, absolutely fascinating what people can come up with. We'll be probably going back to Bubba Is You, I think, at the beginning of next week. So I'm looking forward to that. Now, today we hosted, Simon and I were the guest hosts on a forum from the World Sudoku Convention, which is on at the moment, and that panel discussion with some very good constructors can be seen at a link that I will post below the video. So do go to that if you want to see an hour and a half's chat about puzzle construction, which I think is very informative, actually. Really interesting guys. We had Thomas Snyder, Gareth Moore, and Prasanna Seshadri. Many of you will know some or all of those names, and you can watch them discuss, prompted by a few questions from us and from the audience who was there. You can watch them discuss some of the aspects of puzzle construction that do interest people. So that is on a link under the video. You can also find links to our merchandise, which has been going incredibly well. I'm not going to say that's just because Simon started mentioning it and showed a few pictures, but it probably is. But there are clearly hundreds of people walking around out there with wearing our merchandise, and we're delighted with that. Thank you for the kind comments about it as well. What else have we got? All our apps, they're all there as well. And the URL for our Patreon site. Now, there are only 2 days left on the PBN Institute prize Sudoku hunt. If you have not done that and earned your degree already, if you haven't started it, I wouldn't start now. You won't get it done in 2 days. Well, you'd be very good if you did. But 4 p.m. on the 20th is the deadline, our time, for sending in the final code for that one. And do give it a go. If you're a long way in and you don't have many left to do, try and finish it off. But otherwise, well, good luck. Anyway, let's have a look at this puzzle. Now, how can you have no squares in a Sudoku puzzle? It's almost oxymoronic, isn't it? But Joe Moed, who wrote to us very kindly, said he's a big fan of the channel and he's been inspired to set a puzzle, has come up with this fascinating rule set. So I will explain how you can have no squares in a Sudoku puzzle. Normal Sudoku rules apply. A pair of orthogonally neighbouring cells cannot be read as a square number in any direction. Hence, no one can ever neighbour a 6, etc. Now, what does that mean? That means because 16 is a square number, you can't put a 1 in any of these cells, because if you did, you could read a pair of orthogonally neighbouring cells, or a domino, that was what Joe actually called it in his rule set, as 16. If you put a 1 there, you'd be reading 16, and that's not allowed. If you put a 1 there, you'd be reading 16. If you put a 1 there, you could read a 16 backwards, oops, there, or there upwards, and that's not allowed either. So in any direction, there are no 2-digit squares readable in this puzzle. That's an important rule. Now, we also have a couple of cages, just 2 of them, and they each sum to a square number. So there are a couple of squares in this puzzle if you count the totals. I mean, obviously that's a square on its own and that's a square, but these 2 will help us solve it, I presume. It's a fascinating, it's a huge negative constraint rule, really. I have no idea how this is going to play, but do give it a try if you fancy it on the link under the video. Really interesting rule set, actually. I'm very impressed, Joe. I mean, and that this solves with just those little cages and what? Probably going to miscount these, I often do. It looks like 11 givens to me. I don't know. I mean, fascinating. Give it a try. I'm going to start now. Let's get cracking. So let's think about what these squares are. That's important. I'm just going to where have we got to write them? Okay, I'm going to write the available squares in this section just so that I've seen them once each. I'm not filling in numbers. I'm just writing 16, which is 4 squared, 25, 36, we're up to 6 squared, 7 squared, 8, no, 8 squared is 64, 9 squared is 81. So these are the 6 squares, 16, 25, 36, 49, 64 and 81. Now what do we notice about the numbers? Well, 6 appears 3 times. 6 in this puzzle can never be next to 1, 3 or 4 accordingly. 4 is there a couple of times, can't be next to 9 or 6. 1 can't be next to 8 or 6. 3 also can't be next to 6. 2 and 5 only appear once each next to each other. So that's the only restriction on them. And 7 is not in this list at all. So 7 is like a rogue number that we have no control over. So you can, if you want, put up a list like that next to the puzzle. Maybe if I remember, I will put one up on the solve of this. But I'm not actually going to use one because I think I can remember those numbers. I have played enough puzzles and numerical crosswords that use that set of squares that I will probably remember them. So let's see. 6s seem very important, don't they? So here, around this 6, 1, 3 and 4 can never touch it. So they can't be in any of those cells. So 1 must be in one of those two, because of that one. That 3 says that 3 is up there somewhere. And then 4 can be in any of those, but it doesn't really get us started. This adds up to a square, so that's 1, 4 or 9. This has too many possibilities to think about at the moment. I don't know, what else? Right, where does 6 go? This box has got 3 given digits in it. How generous, Joe. Where does 6 go in this box? And that is interesting because it can't be next to the 4 because 64 is a square. It also can't be next to a 3 because 36 is a square. So 6 is limited to one of those cells. Yes, and this gets us going a bit, I think. Where does 3 go? Well, obviously those 3s, which along with 2 4s, the only duplicated digits given to us, mean that 3 is in one of those cells. But look, this is important. You can't put 3 here because of what we've done with 6. Remember that 36 is a square number and 6 is in one of those cells. So if 3 was here, it would connect up with a 6. It can't do that. So now 3 must be in one of those 2 cells along with 6. Now this can't be a 1 because it would be next to 6 in whichever cell it is. So this can't be 1, 3, 6, 4, 9, 5, 2 or 8. It is a naked single of a sort, and we can put in 7, the rogue digit that can go anywhere. Okay, I'm going to fill in 7 as a candidate in one of those 3 cells. Now, what else have we got to put in here? 1, 2 and 8. Are there restrictions on those? Have I forgotten any square numbers? 1 can't be next to 8. Oh, or 6, but I don't know which one is 6. 2 can't be next to 5. 8 can't be next to 1. So no, I don't think there are any helpful restrictions going on yet. Okay, let's have a look at row 5, where we've got rid of the 7 at least. 4, 7, 9, 2. We've got 1, 3, 5, 6 and 8. Now, this can't be a 5 because of the 2 or a 6 because of that. So it's 1, 3 or 8. Where does 6 go in this box? It can't be there because of the 6. It can't be next to the 4. So it's in one of these 3 places. And 6 is the digit that is most helpful to us because it's the most restricted, but I don't think I know where it does go. Hang on. 6 can't go next to the 1 down here. So 6 isn't in those cells or those 2 because of the given 6. Right, 6 is down over here somewhere. So now 6 is in one of these 3 cells, but it can't be next to the 4. So 6 is going to end up in one of those 2. 4, 7, 9. So if that was a 6, this would have to be an 8. It couldn't be a 1 or a 3. Then we'd have 1, 3, 5 here. Can't see how that helps. 6. No, I'm not sure. Okay, I'm going to need to find something else. Sorry if I'm missing something. There's every chance of that. Where does 2 go in this row? Can't be next to the 5. Can't be in those cells because there's already a 2 there. So 2's in one of those positions. It's not that helpful, actually. Ah, 9. 9 can't be next to 4, can it? So 9 is in one of those 2 and one of those 3. Now things are getting a bit clustered up here. 5, 7, 9 and 4 and 2 can't be in... What's this one? This can't be 5, 7, 9, 4, 2 or 1. It can't be a 6 because it's next to 4. So that is 3 or 8. This one can't be 5, 7, 4, 9, 2. It can't be 6 because we know 6 is in one of those. Well, and it also can't be next to a 4. So that is 1, 3 or 8, is it? So have we got a triple going on here? I think we have, yeah. 1, 3, 8, 2, 4. So this is 5 or 6. These are from 5, 6, 7 and 9, if I've done this right. That can't be a 5 next to the 2. Now, are there any of those that can't be next to each other? 7 is a rogue. He can be next to anybody. 9 is trying to avoid 4 only. I think. Yeah. Okay, that's not... Ah, this can't be a 6. Because these can't both be 8. One of them is 1 or 3. So that can't be a 6, so that's a 5. Oops, 5 is what I'm trying to write in. This, oh, I've somehow got the conflict checker turned on. I think I'm in the test software, that's why. There we go, so let's turn that off again. Right, 6, oh no, it could be here. I thought it was going to put it here. But they don't have a 5 in. This is a 6, 7, 9 triple now. Let's just remove the pencil marks because I don't think I need them anymore. The corner marks, I mean. We keep the 6, 7, 9. That's looking across at this. That becomes a 3. 6 there stops that being a 1. Ooh, now 6, 5, 7, 4. 7 is not. 2 can't be there. Oh yeah, 2 is there or there. No, have I missed something here? 7, 9. No, I don't think I have. Got a 6, 7, 9 triple R. Oh yes, look, I've missed that those 6s are pointing there, so I can put in 6 in this cell. Right, and this becomes not a 4. Don't know what to do next. 6, 7, 9, 3. So 4 and 4 has to be in one of those 2 cells. Can't be next to the 6, remember. 5 is in one of those 3. These are from 1, 3, 6 and 8. 6 is in one of these. But it can never be next to 1 or 3. So this can't be 6, or it would be next to 1 or 3. And if it's there, that's an 8. And if it's there, that's an 8. So that's an 8. So none of these are 8. 6 can now go in either of those positions, I think. The other one is obviously 1 or 3. Are there any restrictions on those that I've forgotten in this row? I don't think so. This is a fascinating puzzle. I did not expect it to work in this way at all. I've still not got anything for this cage. It's very hard to get out of these rows, but maybe I'll just keep trying to milk these rows. 8 is now there. Oh yes, 8 is in one of those two cells. I could have noticed that ages ago. That makes that a 2. Right, so we're down to 1 and 8 up here. This is now a 2, 4, 5 triple, in which that can't be 4. 2 and 5 can never be next to each other. So they have to be apart. They have to be kept apart by 4 acting as chaperone this time. 4, 2, 5. So 9 is down here. 6 must be in one of those. I know that. Okay, maybe I can approach this cage now. Now, I reckon this adds up to 16 or 25. To add up to 16, those add up to 9. They now can't have a 4 in. So they're either 1, 3, 5 or 1, 2, 6. To add up to 25, these add up to 16. They're going to have one high number. They're going to have a 9 in. And then 9, 6, 3. Okay, so there's only 3 combinations that will work. If it's 3, 6, 9, 3 and 6 have to be kept apart by 9. If it's 1, 2, 6, 1 and 6 have to be kept apart by 2. And if it's 1, 3, 5, well, by Sudoku we got a 5 in the middle and 1 and 3 either side. So every which way, those are from 1, 3 and 6. Is that incredibly helpful or not very? I don't know. I can't see how it is incredibly helpful, annoyingly. These have been reduced to a 1, 3, 4 triple, haven't they? I hadn't really figured that out. I'm going to put in the central marks just because that makes it easier for me to recognize that that's a triple. If that was a 4, that would be a 4. It couldn't be next to a 9. I don't think I can use that yet. 2, 6, 5, 7, 4. These are from 1, 3 and 9. They can't be 8 clearly. Wherever 6 is in these cells, it can't be next to 1 or 3. So it must be next to a 9 down here. So one of these is a 6, 9 pair. The other is a 1, 3 pair. And I don't know how to use that. Right, 6 down here can't be next to the 3. And now it can't be there. So 6 is in one of those 3 cells. 6 at the top is in one of those 2. 1 can't be next to the 8, so 1 is up here somewhere. I've got 2, 5, 7, 8 and 9 to fill in there. 9 can't be next to 4, but neither of those actually forces it to be, so not very conclusive. 2 and 5 can't be next to each other, so no, that doesn't mean that's not a 2. 7's a rogue. Got no ties on 7. Oh, okay, it's a bit stuck again. 3 can't be next to 6, so that's not a 6. Oh, that's not a 6 either. So 6 has actually only got 2 places in row 3. If it was there, that would have to be an 8. Oh. No, I thought 1 couldn't go there for a second. That's not right. Can I do any more with that? I don't think I can. Oh, what am I missing now then? There's nothing going on there. I suppose if that was 1 or 4, we'd have a 1, 3, 4 triple. What does that mean? They're the digits that can't be next to 6. It's not doing anything for me. I can't see any joy there. 1 can't be next to 8, but that's not a problem in the row. It just means those can't be 8, but that can be. Oh, okay. I'm sorry if you're seeing something very obvious and shouting it at the screen. I'm not hearing you at the moment. I might easily be just missing some obvious move. Now, if that was a 9, 2 and 5 would have to be separate up here. If it was a 9, it would be going with 6 and 3. 2 and 5 would be next to a 1. That's not actually helpful. Oh, sorry about this. This is not going well now. I must be missing something. 8 is just... Oh, 8 can't be next to 1. There we go. That's what I'm missing. Right, so that's a 3-6 pair. That's a 1. Okay, sorry. I heard you in the end. It took a long time. They can't have a 3 in. Those are a 1-9 pair. Do I know which way around? No. But whichever one of these is a 6 has to go with the 9. So there's a 3-1 and a 6-9, one side or the other. Right, now this 1, well, I mean, it tells me one of those is a 1, but I kind of knew that already. In fact, I could have used that to get the 1 there. 2 ways of easily getting to the same stage, and I wasn't doing it. Have I really achieved nothing else? No, I don't think I have. Right. Maybe it's worth remembering that 8 can't be next to 1. So that's not an 8 because one of those is a 1. So either that's an 8 or 8 is in one of those cells. Not that useful. 5. Probably missing something else obvious if I was doing it before. This is the sort of puzzle where you really can miss things that in hindsight are very obvious, as you can see at the moment. This can't be a 6 or a 1, or 4, 8, 7, or 3. So that is another 2, 5, 9, a bit like that one. Oh, it can't be a 9 actually, because it's next to a 4. So that's 2 or 5. That means this can't be 2 or 5, or you would get 2 and 5 next to each other. 1, 3, or 9 remain. 1 or 3 would force that pair. 9 would have an impact on that. Maybe this can't be... What is it that goes together? 6 and 1 can't go together, so 3 and 1 or 6 and 9 must be there, and they will have an impact on that. It's not enough. It's not enough information. Oh, this is tricky. Right, what about this? Can't be 3, 8, 1, 9 or 5. 2, 4, 6 and 7 can all be next to 8, annoyingly, so that's not really telling me anything. 6 in this row can only be in one of those positions. This isn't it. Come on. Let's just have another little think about what we can get done. Oh, 1? No, 1, 1, 1 in one of those. 6 up here. Can't be next to a 1 or a 4. They don't have to include a 4. That can't be... No, nothing interesting. 6 or 8, but it already can't be those. Wow, I'm really not getting on with this, am I? This is the problem with looking for negative constraints. It's a bit like looking for a needle in a haystack. You're okay if you find it, but if you don't, it doesn't prove it's not there. If that's a 3. Then we have 1, 4 here. 6 must be down in one of those cells. 7, 8, 5, 9. I just don't think they're useful digits. If that's a 3, that's a 3. And 3 ends up in one of those two. I don't know, I should focus more on 6s, shouldn't I? Because I've got very little else. Those can't be 6, that can't be 6, that can't be 6, that can't be 6. So 6 is in one of these places. Either of those forces a 6 into here. But there are 3 possible combinations. They all have a different digit here. Oh, come on, Mark. What on earth can we do? Row 1 can't be next to 6. In this column, 4 can't be there or there. So 4 is either there or down here. If it's over here, that's a 6-4 pair. Then you'd get 1, 3, 4. Oh, a 4 here would make that a 1 definitely. I think that works. Maybe there's a problem with a 4 here, which would put a 4 in one of these two. I don't see how that causes a problem. I mean, you could even have 9 in the other one. Goodness me. Okay, these can't be 4, and that's next to a 6, so that can't be 4. Anything else where 4 can't be here because it would be next to a 6, and it can't be there. So 4 is in one of these 3 places. Now, is one of them a problem, or 2 of them would be even better? Four in one of these would force 6 into the other. Then you'd get 4 up here sharing space with a 1. I cannot see the problem. Wow, and I keep now just repeating the same thoughts in my head, which is very annoying once that happens. 5 can't be in those or that. 5's just not a helpful digit, but then at the moment none of them are. Okay, having another look at row 8 now. Maybe I need to consider these combinations a bit further. So if that was 3, 6, all 3 of these combinations are possible. So if that was 3, 6, this is a 9 to make 25. So then we've had 3, 6, 9. This becomes a 1. And that's 2 or 5 along with that. If it's 3, 1, that's a 5 to make up 16. That's a 2, 9, 6 at the top. Ah, that's impossible. Because if you had 2, 9, 6, this couldn't be 1 and 4 and be the next to the 6, and it couldn't be 9 because we've already had it. So this can't be 2, 9, 6. So this is not a 5. So 5 is one of these two digits in the column. Now, what about the other one I didn't consider? That is 1 and 3. No, that's what I've just considered. So one of these is a 6. That is what we've just discovered. Okay. And I thought about 6 and 3 earlier. Now I think about 6 and 1, which make this a 2. So that's use 6, 2, 1. 7, 8, 4, you get 5 and a 3, 9 pair above, which stops this being a 9. Three, 9 pair up here. So in that version, this is 3 or 9, and that's not. And in the first version, if this was 7, 6, 3, 16 with a 9 there, this is 1, 7, 3, 6, 9, 8, 4, 1, and that's 2 or 5. That's not really narrowing things down enough, is it? Still, we eliminated one of the possibilities. We got 5 out of there. Is there anything else we can do with 5? If this was a 9, oh my goodness! If this was a 9, where are you going to put? Where are you going to put 4 in row 8? That's really interesting. 4 can't be there because it would abut a 6 in column 3. Same in column 9, it can't be there. It can't be there because of that 4, and it couldn't be next to a 9 in one of these two. So in fact, the simpler question is, where is 4 in this row? For those same reasons, it can't be there or there. It would touch a 6, can't be there. It must be in one of these two, and now that has to be a 2. Wow, that is a fascinating step. So we get a 5 there. Now, to make this cage add up to 16 now, these are 6 and 1. Let's remove the... Right. 1, 6, 2. So this is a 3, 9 pair. That's not a 9. It's 1 or 4. Ooh. Oh, yeah, lovely. If it's a 4... that can't be a 4 and becomes a 3, and this can't be a 9 because of 49 and also becomes a 3. So that is a 1. That's not a 1. This is a 1. It doesn't fix this. I was hoping that would become a 4. 3, 4 pair fixes that as a 9. So we've got most of this column done now. 3, 3. 3's not very helpful. 9's not very helpful. We already know there can't be a 4 there because of the 3, 4 pair. But 2 now can't be in those cells. Is that interesting? Probably not. Because only 5 is... 5 is now not in those cells. So 5 is in one of those two. That doesn't really help. Right, let's have a look at this row again then. 2 can't be next to 5, so 5 isn't in those or there. So, oh no, it's an X-wing, but not a relevant one, not a helpful one. 5 is in those spaces in columns 8 and 9. Fair enough, but it doesn't get anything done. I didn't ever think 2 and 5 were going to be useful digits, and they're really not being. Right, what about 4? That pair of 4s says that 4 can't be in any of those cells now. Anywhere else here. So 4's in one of those 3. I don't really want to pencil mark that because I might misinterpret it at some point. Gosh, this is tough. I'm 35 minutes in. This isn't... I'm sure there's quicker ways to get through this, and sorry about that. But let's keep going because we've made some progress now. Oh, that 1 is now looking down at this. 9 and 1. So this can't be 6, so that's 3 and 6. Now, where's 6 here? It's in... Oh, it can't be there or there because they're both next to 3s. So 6 goes in here and here. So that's not 6. Now this isn't 1 and this isn't 1. Oh, this is monstrous. Right, but we're getting somewhere. 8 ends up in one of those two. 6, 9, 1, 3, 4. If I knew that couldn't be 8, I could place it here. And I don't. 7 is a useless digit, remember? 6 and 8. I just cannot get used to understanding what findings are actually helpful in this puzzle. 6, 9, 1, 3, 5. So we've got 2 must now be in this row in one of those two cells because it can't be next to 5. 4 can't be here. 8 can't be here. That's just not quite enough information. Oh, yeah, 2 in this row? No. Looked at that before, I think. That's a 3 X-wing. So 3 is now in one of those two cells, which doesn't quite tell me anything except that 6 won't be next to it. But 6 could still be there. Now, is this row really not helpful? 3, 8, 2, 1, 9, 5. 4, 6 or 7 there. Can't be a 4 because we know 4 is in one of those cells and that would put it next to a 6. What? 7 is a rogue. He can be next to anything. He's annoying me. 3 or 1, 4. 3, 4, 6, 1, 5. 2, 7, 8, and 9. That can't be 2. I still think it can be 7, 8, or 9. These two can't be 8 because of the proximity to 1. So one of those 3 is 8. And 9 can't be next to 4. That's just not helpful at the moment. Okay, 1, 3, 5, and 6 are confined here. 2 has to be in one of those. I wish I could say 2 couldn't be in those cells, but 5 could be there, so it could. Five we know is in fact in one of those two, don't we? What does that do? Doesn't really do anything. 5's in one of those 3 in box 7. Goodness me. I've done these square digits. Oh, that can't be a 1. Right, that's really very basic elimination. So we get a 1 there. One of these two is a 1. These are from, that is 5 or 7. This is 5, 7 or 9. There's a 1 there. 6, 1, 3. Now, what else am I missing up here? 7 I cannot control. 9 is in one of those 3 cells. It can't be next to 4, but it's not trying to be. 3 can't be next to 6, 5. What have I forgotten? 8 can't be next to 1. That's the one I keep forgetting, so I should have kept the list handy, really. 8 goes there. So next time I don't know what to do, try and remember 8 can't go next to 1. Yeah, that could have got me a 1 there somewhere much earlier. That is my problem. Right, I'm going to have to get better at remembering that 8 can't be next to 1. So I'm probably looking at something totally obvious. Now, yeah, look, 8 can't be there or there now. So 8's in one of those cells. And that fixes this as 3, 8. And that goes up here and fixes 3, 4. Now, 4 there, 4 there. 4 has to be in one of these cells, but can't be next to 6. So those two have to be a 4, 6 pair. 2, 3, 5, 7, and 9 still to place in the column. 9 can't be next to 4 though. So that's 5 or 7. Oh, come on, keep going, keep going. 4, 6, 3, 1, 2, 5 or 7. Ah, but interestingly 2 and 5 can't be next to each other, so 7 must be in one of those two cells. That's not 7, that's also not 7, that's 2 or 5. 6, 8, 3. Well, 4 can't be next to 6, so 4 goes here. And then can't be here, so 4 in column 2 is there. That's fixed 6 and 4. That fixes 6 and 1. That fixes 1 here. Come on, keep going, get on a roll. 6 and 6, yes, that's 6. 2, 1, 4. Can't be here next to the 6, so it goes there. This is from 5, 7 or 9. And so, oh no, this can't be 5 because it's next to 2. So that is 7 or 9. What is it? 9 can't be next to 4. So that's a 2, 7 pair. That's what's happened here. Oh, 2 can't be next to 5 though. So 5 and 9 can't be next to 4 again. That's not a 7, so that's the 7 in the top row. That's 9. This is 2, or that's a 2, 5 there. Here we go. 2 there. That puts 5 here. Now I can do 7 and 9 in the final column. That I can do row 8, 5 there. 3 can't be next to 6, so 3 is there. What a puzzle. 2 goes there. This is an 8, 9 pair. Which one can't be next to 6? Oh, 8 can't be next to 1, my bugbear. 3 and 7 to go in here, but I don't think they are constrained yet. Oh, they are by the 3 in column 4. I'm losing it so much I was about to point at that on my screen as if that would help. 5 and 8 here. 5 can't go next to 2. I think we're finishing now. 5, we get a 2 there. 7 and 8 in row 2. They are done. We get 8, 9, 7 and a 4 to finish. And I think we are done. Wow, that is fascinating. I do want to check. Let's first of all just make sure 4s are never next to, no, let's do 6s, never next to 1, 3 or 4 to make sure, because the software won't check for this. It'll just check the normal Sudoku rules. So I'm going to do a quick manual check. Yeah, that works. 2 never next to 5. That is a symbiotic pair. That looks all right. 4 never next to 9, and then I will check 8 never next to 1, and I should have covered all the bases then. Yeah, that looks all right. 1 and 8. Wow, okay, that is the answer. So what a puzzle. Thank you, Joe. That's really interesting. I'm not sure I'd want to do another one quite that sparse with the same rule set, but that was good fun, and I've enjoyed that. Hope you had a go at the puzzle. Hope to see you again on the channel soon, but as it is, bye for now.